Pan-STARRS 1 was the Hawaiian telescope that first saw this rocky interloper, but soon experts across the planet were making their own observations, including Alan Fitzsimmons of Queen's University Belfast, and were already seeing their results.
I remember opening up my email that morning, looking at the announcement and thinking, oh my God, we've been waiting for something like this to be found for decades, and now it's here, and it looks like we haven't got much time to observe it, so we'd better get cracking.
One of the things for me which is so interesting is we were told there was something that had come from outside our solar system. Everyone was trying to get their best view of it, and already there are papers being published. There's one appearing in Nature. The archives on the net are full of analyses already.
That's right, and more coming out in the next few weeks. The important thing is that people knew they didn't have much time to observe this because it was only spotted when it was already past the sun and on its way out of the inner solar system. Right now, only the largest telescopes in the world can actually detect this object, so you had to get your data as quickly as possible, when the object was as bright as possible, of course, as well, because we study these things via their reflected sunlight, and the closer they are to Earth and the closer they are to the sun, the brighter they appear. And now that chance has gone, and so as we see this object disappear back into interstellar space, we've pretty much got almost all the data we can, and why hang about? Let's just get it out there and start sharing our discussion.
As you say, you saw it when it was already leaving the solar system. It sort of came in from the wrong side of the sun, as it were. And how fast, compared to, I don't know, a comet or a planetary orbit, was it moving?
It was moving substantially faster than a comet or an asteroid or a planet going around the sun at each point in its orbit, and that's how we knew it was from interstellar space. It was moving too fast for gravity to keep it around the sun, and certainly when it was its closest point to the sun, it was moving at over 80 kilometers per second, which is moving a fair bit. But as you say, we didn't unfortunately see it on the way in, because not only is it small and faint, but it was also pretty much in the daytime sky. We could only see it when it came out from behind the sun and got within range of our telescopes.
Now, the most important piece of information we've got so far is what it looks like, what this object actually is.
Yeah, now we've got to remember that even in the world's best telescopes, this thing only appears as a dot of light. But by seeing how its brightness changes as it spins around its own axis, just as the Earth spins around its axis once a day, we can figure out not only how fast it's rotating, and it's rotating a bit faster than once every 8 hours, but we also get some idea of its shape. And this was one of the first really big surprises with this object. It's incredibly elongated. It seems to be at least 10 times longer than it is wide. It's kind of an interstellar cigar, or whatever kind of long, thin thing you want to imagine.
I mean, you say cigar-shaped, that's to me rocket-shaped. Is there any way that you would know that this was an interstellar rocket?
Well, there's a few things that we would see. First of all, it's a strange thing to get your rocket to do, because it's just following the force of gravity as directed by the sun. It's not slowing down or speeding up beyond that.
Maybe they ran out of fuel.
Maybe they ran out of fuel, but also it's rotating not that fast around its axis. But as I said, it's been a little less than once every 8 hours, which means that if you were standing right on the tip, you would feel some kind of centrifugal force, which you could take for artificial gravity, but it'd be pretty low. And secondly, when we look at the colour of the surface, it looks like an object we would expect to appear if it was natural. It does not look like metal.
And when you say it looks like something natural, you mean it's not a processed material that some technology would have made?
That's right, as far as we can tell. When we see objects in our own outer solar system, we see them developing a dark red surface due to the irradiation of their surfaces by energetic particles from outer space. And that's exactly what would have happened to this object as it journeyed between the stars. And so if there's one thing that wasn't surprising about this object, it was how it reflected the light and what it tells us about what its surface is made of.
So the assumption is that this has come from some other star which has a planetary system like ours, but instead of a thing on the edge falling into its solar system, it fell out somehow and has been flying for millions of years our way.
That's right, but our own solar system has done that too. 4.5 billion years ago, our planets formed around our newly formed sun, and planet building, we now know, is an incredibly messy and wasteful process. And those early few million years ejected a huge number of objects back out there into the galaxy. So it's not a surprise to us that we would see occasionally one of these things reaching us from another star. In fact, we've expected it.
You've expected it. I mean, any idea how long it's been travelling, how far it's come?
Well, astronomers have looked back along its trajectory, where it's come from. There are no nearby local stars that are obvious to us, but about 250 light years away, there is a region of star formation where interstellar clouds of gas and dust are collapsing at this moment to form new stars and planets. So it could have come from there, in which case it would have taken about 40 million years to get here. But there's no guarantee at the moment that that is actually its origin, and it could have been out there for an awful lot longer.
And finally, Alan, I've avoided calling this asteroid, whatever you call it, by its proper given name. It is?
It is, I believe, Oumuamua, which is from the native Hawaiian language. It means, if you like, roughly first emissary or first scout, because we hope to find more of these things.
Time to go and learn the Hawaiian for second emissary, or even more, please. Alan Fitzsimmons on a tantalising glimpse of the stuff that other solar systems are made of.